There's a lot you'll learn in this episode. First, why, what, and how of computer science. We'll do a quick overview of computer science and why I think it's important. Next, we will run your first program and deal with the inevitable errors. Finally, we're going to pull back the curtain, give you a tour of what's going on underneath inside the computer so you can build a better mental model of what's going on. Hi, everybody, and welcome. My name is Ricky Chang. I'm the host of this AP Computer Science A tutorial. I'm an ex-Microsoft software engineer and an ex-Google product manager with 30 years of experience in the tech industry. I want to help busy students like yourself to get top scores in their AP CSA exam. This is the first episode, and I will cover why computer science and what's in it for you. Let's get started. As a veteran of the tech industry, here are my top 3 reasons to learn computer science. First, computers are essential. They are the engines of the modern world. Did you know that there are 1 trillion semiconductors produced each year? Everything is becoming like computerized, like cars, TV, doors, even toothbrush. The list will only grow. Second, professional growth. Computers are simple underneath. Some might even say they're stupid. All their smarts come from people that instruct them to be smarter by using computer science. Computer science will advance your career, and you don't need to be a programmer to take advantage of it. You'll become a better user of technology and accelerate your career growth. Finally, personal growth. Learning computer science will build better mental models to solve complicated problems. Computer science is the study of computability. I know that sounds very circular. Let's talk about some examples. You can have a simple problem about converting inches to centimeter. It's a basic formula. It only takes 1 step. Divide the number of inches by a constant number and you get centimeters. But we can have complicated problems. Imagine you are the Uber Eats system. You want to help all the drivers to pick up and deliver all the food and get them home quickly. That is a solvable problem with a famous procedure called traveling salesman. Stepping back a bit more, there's a unifying concept in computer science I like to describe as time and space. Given a finite space as measured by the amount of memory used, and a finite time as measured by the number of computations performed, is there a way to find at least 1 correct answer efficiently? I know that's a big concept. For now, just remember time and space. We'll be revisiting this concept over and over again. How are we going to learn computer science? College Board decided to use a subset of the Java programming language with a focus on computational thinking and problem solving. Computational thinking is just a fancy way of saying you'll learn to think like a computer. You'll learn to read code and imagine the outcome that the computer will generate. On the other side of that, you'll learn to take a problem, then design and write code to instruct the computer to solve it, just like reading and writing a foreign language. The language we'll use is called Java. It's one of many computer languages available. Generally, any problem that can be solved with one language can be solved with another. So all the concepts you learn in this tutorial are foundational and applicable to all modern programming languages. Finally, the College Board has revised the curriculum for the fall of 2025. You can be confident that this tutorial will be based on the latest revision and tightly focused on only the things you need to get a good score in your AP exam. Enough talk about computer science. Let's write your first program. We'll be using an online service which encapsulates all the software needed and put them in an easy-to-use web browser. Feel free to pause the video, open a new browser window, and type nextleap.app/online-compiler/java-programming. I will switch windows and reload. As you can see, a default program has already loaded. Your program will say hello to the world. Do a quick walkthrough line by line at a high level. The first 4 lines are comments and spacing. Okay? These are notes that programmers leave for themselves and other programmers, what this program is about. Line number 5, we will spend quite a bit of time discussing what's a class. Think of it as a way to organize code. Line number 6, this is a programming convention. This is the starting point where I'm going to start doing stuff. You can write a lot of code before this, you can write a lot of code after this, but you always know main is what we'll kick off. Okay. The other part, you can see that when I have the code highlighted, There's another part that also, I don't know if you can see it very clearly, but this is the part that's also matching. This is kind of lightly highlighted by this editor. Okay? And these are matching curly brackets. So that represents the block of the starting and the ending of a particular section of code. So 8 and 9 are just closing blocks to the things we talked about for the class and for the main function. Number 7 is where we'll spend more time focusing on for today. And this is where the actual first instruction, where the system is asked to do something. Let's see if we can walk through and guess what it means. System.out.println, parenthesis, colon, hello, comma, world, exclamation mark, closing colon, closing bracket, and semicolon. Well, looks kind of big. I bet you can probably guess what this is trying to do. Okay. System, in this case, it means the computer environment that this program will be running. Out, it means output. We want to show something to the user. And what is that we want to show? Print ln. The ln stands for line. So print line, hello world. Okay. You can probably guess everything in the brackets is the thing that we want to show. Let's practice some computational thinking. I want you to carefully think about what is going to show up on the output side. Okay, very precisely. Okay, are you going to see any part of the statement? Are you going to see the quotes? Will you see the comma, the explanation points? Try to picture it as clearly as you can. Press the run code button. Okay, let's run code. The execution in progress. Voila. It says everything inside the quote showed up and nothing else. Okay, was this what you expected? Very good. You have ran your first program. Let's make some changes and see what happens. I explained that println is the thing that generates output. Let's do something similar again. I want to do, println, my name is Java. This looks vaguely like the line above. Let's try it and see what happens by hitting run code. Wow. Is that what you were expecting? Compile error. Big red error message. Okay, that looks that looks kind of scary. Freaking errors. Same as learning a new foreign language. You will make mistake. Now, you might mispronounce some words. You might not follow the grammar structure exactly. When you're talking to a native speaker of another language as a beginner, and overlook many errors. Unfortunately, that's not how Java works. It is pedantic about all the various rules. There are good reasons behind it, but as a beginner, it's very frustrating when it doesn't understand something and give up. Don't take this personally. It's just Java way of saying, I need help. It will try its best to tell you where it got lost. And it might even give you a suggestion or two on how to fix it. So let's go back again and kind of look past the big red errors and see if we can understand what's going on. Okay. So it says main.java. I think this is the file that we're in. Okay. 8. It means the line. And you can also see it tries to be helpful and underlines it. So line number 8 has an error. And it says error, semicolon expected. That sounds good. So I don't know why a semicolon is expected. We will go down more into that later. That sounds good. Let's go with it. Right. Let's try again. Why is it giving me another error? We know we only wrote one line. If there's another error, this must be the source of it. Let's see if we can find out. Line number 8, error. Cannot find the symbol println. You just use system.out println in the line above. And like a normal human would likely understood. You're probably talking about the same println. Okay. Unfortunately, that's not how Java works. Okay. There could be many, many printlns. If there's any kind of ambiguity about which line of println, or you don't have the full name of the println, it's going to get confused. And that's what happened here. Notice that in this case, it doesn't have any suggestion. And even the tools, the suggestion it gave you is to remove this line. Not very helpful. But since we know our intent is really system.out, so let's type in the full name of this symbol. Let's try again. And voila. This time you got 2 lines. Hello world, my name is Java. First attempt to write this code, there was actually 2 errors that it caught, but it stopped as soon as the first error with the missing semicolon was detected. It didn't know to try to find as many errors as possible. And when you fix the first one, it's able to proceed and find the next error. And you're going to see that again. You're going to see this pattern a lot. So we'll talk about in the future how to use this to your advantage and how to make the work a little easier. Let's make one more edit. and just add a period to make it more consistent to the line above. Do you think there's any error here? Probably not, because you know everything in the between the quotes will get displayed exactly as it is. There's nothing here is really programming related. So we'll make a very small change. Boom, the period now is there. Let's revisit it, but I think this is a really important concept. There's a mismatch between you and the Java compilers, right? You as a novice do things that are, unexpected. Java needs to be very pedantic. There are lots of rules it needs to follow. And if one is not sure what's going on, it's going to say stop. Don't take it personally. Okay. Sometimes it gives you suggestions, sometimes it don't, but just step back and think about what it is you're trying to do and think of the rules that you have learned about programming to see if you can catch the error because you're doing something that's not quite what Java wants. Don't get frustrated and then you'll get through it. Okay? So errors are normal. You'll learn to make less and less errors as you go. Computer can do amazing things. I think it's still pretty magical, but like the Wizard of Oz, behind the curtains are people and simple devices making the magic happen. Let's take a tour inside the computer about what's going on so you can better build a better mental model. This is a vaguely English-like code that you have written. Java takes your high-level instruction and then it converts it to machine instructions. All these zeros and ones is going to put it into the memory unit of the central process unit. And that is the brain of the computer. Once it puts that set of binary instructions into the memory, it's going to start it off the control unit and says, okay, here's the first thing you need to do. And then CPU would just go back and forth and keep pulling that instruction and do what it's told to do over and over again. Next instruction, next instruction, next instruction. Along the way, you can grab some input from the user, or you can show some output to the user. In this case, we only have a simple output called hello world, and it's going to put that to the user. There you have it. You now have a better understanding of why and what and how of computer science. You successfully ran your first program, made some changes, fixed some errors, and got your changes to work. You know that your instruction is what makes the computer capable and smart. And that's the important thing. As you learn more programming concepts, you'll become a better programmer, and you'll be able to tell the computer to do more complex and interesting things. And I think that's a pretty good thing to look forward to by the end of the class. Here's a quick preview. You'll learn more about the other subsystems of the central process unit. We'll learn about variables, how to pause a running program, data types that exercise the arithmetic and the logical units, and take advantage of this edit, compile, and run cycle. So you can start with a small program and gradually and carefully build a more and more complex program as you go. Please give your feedback in the comment section below. Your feedback and encouragement will help this community grow and better serve other busy students like yourself. Thank you for listening.